Hello and welcome to the GCO Podcast, where we delve into the most innovative and transformative ideas in civil engineering. I'm your host, Andrew, and today we have an exciting topic that combines the heights of urban architecture with the depths of renewable energy. Yes, we're talking about turning skyscrapers into gravity-based energy systems. In the realm of renewable energy, innovative solutions are constantly being developed to address the growing global demand for sustainable power. Among these cutting-edge technologies is the concept of transforming skyscrapers into gravity-based energy systems. This revolutionary idea leverages the principles of gravity to store and generate electricity, presenting a promising alternative to traditional energy storage methods. Let's start by understanding gravity-based energy systems. Often referred to as gravity batteries, these systems operate on a simple yet effective principle: the conversion of potential energy into electrical energy. The process involves lifting a mass to a certain height, storing energy in the process. When energy is needed, the mass is allowed to descend, converting the stored potential energy back into electrical energy. A notable application of gravity-based energy systems is gravitricity, a technology that utilizes disused mine shafts and tall structures to create a gravity battery storage system. By lifting and lowering heavy weights, gravitricity can provide a reliable and sustainable means of energy storage, capable of balancing supply and demand in power grids. One of the most exciting prospects in this field is the transformation of skyscrapers into gravity-based energy storage systems. Skyscrapers, with their significant height and structural integrity, are ideal candidates for this innovative application. By incorporating gravity battery systems within these buildings, we can harness the immense potential energy available and convert it into a reliable source of electricity. Now, how do we implement gravity batteries in skyscrapers? The process involves installing a series of weights and pulley systems within the building. During periods of low energy demand, excess electricity can be used to lift the weights to higher floors, effectively storing the energy. When energy demand peaks, the weights are released, descending through the building and generating electricity as they fall. This process can be repeated indefinitely, providing a continuous and sustainable energy solution. Transforming skyscrapers into gravity-based energy storage systems offers numerous benefits, particularly in urban environments. Efficient energy storage. Gravity batteries provide a highly efficient means of storing energy with minimal losses compared to other storage methods such as chemical batteries. A reduced environmental impact. Utilizing existing structures reduces the need for new construction, minimizing the environmental footprint of energy storage infrastructure. A cost-effective solution. The integration of gravity-based systems into skyscrapers can be more cost-effective than developing new energy storage facilities, as it makes use of existing buildings and infrastructure. Grid stability. Gravity batteries can help stabilize power grids by providing a reliable source of energy during peak demand periods, reducing the risk of blackouts and improving overall grid resilience. To illustrate the potential of gravity-based energy systems, let's look at two large gravity battery projects by Energy Vault, nearing completion in China and Texas. These systems store surplus renewable energy by lifting heavy weights, which can later be lowered to convert potential energy back into electricity. A China project. This project, with a 100 megawatt-hours capacity, is being constructed for China Tianying, a waste management and recycling company. It will provide power for approximately 3,400 homes, showcasing the scalability and impact of gravity battery technology. A Texas project. The Texas project, with a 36 megawatt-hours capacity, is being developed for the energy firm Enel. This installation highlights the versatility and adaptability of gravity batteries in different geographical and industrial contexts. Both of these projects boast over 80% efficiency and significant energy savings, offering a reliable solution for renewable energy storage. They serve as exemplary models of how gravity-based systems can be implemented on a large scale, providing critical insights and data for future applications in skyscrapers and other urban settings. However, despite the promising potential of turning skyscrapers into gravity-based energy systems, there are several challenges that need to be addressed. Economic viability. While the long-term benefits are clear, the initial investment required for retrofitting existing skyscrapers with gravity-based systems can be substantial. Economic analyses are necessary to determine the viability of such projects. Regulatory hurdles. Navigating the regulatory landscape and obtaining the necessary approvals for installing gravity batteries in skyscrapers can be complex and time-consuming. The future of gravity-based energy systems in urban environments is bright, with ongoing research and development aimed at overcoming these challenges. As technology advances and the demand for sustainable energy solutions grows, the transformation of skyscrapers into gravity-based energy systems is likely to become a mainstream approach to energy storage. Before we wrap up, I have a question for you, our listeners. Have you ever implemented renewable energy systems in any of your projects? If so, could you share your experiences and the outcomes? Please share your knowledge and experiences in the comments section. Thank you for tuning in to this episode of the GCO Podcast. I encourage you to read this episode's insights and other related content on gcoportal.com. There's a wealth of information waiting for you. Don't forget to follow the GCO Podcast for more insightful discussions on the latest innovations in civil engineering. And be sure to follow GCO Official on social media for updates and more engaging content. Until next time, I'm Andrew, signing off. Stay innovative and keep building a sustainable future.